All right, this is where we step up the game. We're looking at point slope form, which is right here. This should be in your math journals that we're going to keep. All right, so pay attention. We have y minus y1. So if you notice over here, we've got a y, and here's y1 down here, y1, and they're subtracting whatever those values are on this. It looks like they don't really mark those values for us, but they are showing us here what we have. And then we have m, which is our slope. So we can count that over how many this is over and up. But this is the number that's on top, the line that goes this way, and this is the number that goes on the bottom, remember? And then we have x minus x1. So this is our formula we want to remember. It's point slope form, all right? And the next thing it's going to show us here is how to do it using actual data points. They've given us this data point here and this data point here. And, well, actually, they didn't give us two data points. Well, they gave us this data point and a slope, which is, enough information, I guess. Write this in slope form. We don't have a y, but we have whatever this is. We have this value here, and it is minus. So this was a positive, but we're just substituting it in. So we got y minus 1, using that 1, putting in the slope, because that's m, 2/3 slope, x minus, and because this is already a negative, this -6, they put it in parentheses. And when you have two negatives, or you multiply a -1, this is understood, there's a 1 here. -1 times -6 turns it into a positive. So when they rewrite it again, we got y minus 1 equals this and times this. So then the next thing they do, well, that's all they do. I would multiply that in. So they have the formula here. Here it is. And then check that -6 and 1 is the solution of the equation. And then so they wrote the equation, they simplified. Let's see, is it equal? They substituted 1. Oh, okay, I see what they did. They substituted in these values in. So they took the 1 again here. 1 minus 1 is equal to 0. 2/3 of -6 plus 6 equals 0, and 2/3 times 0 is equal to 0. So there it is. It does come out as a solution. So rather than using our line slope format, we're using point slope. Remember, line slope or slope intercept. This is slope intercept, right? Minus b, or is it plus b? I can't remember. All right, but that's slope intercept anyways. And then standard form is, these are things, I've memorized these. These are things you want to memorize. It helps. Minus by equals c. This is our standard form. Here's our slope intercept. And now we have a point slope form, which is right here. Zoom in, you can see it. There you go. All right. Now we're going to write the equation with two slopes, or 2 points of data. In example 1, we used 1 point of data. So on this one, there is no m. If you notice, in our directions, it only gives us 2 points. So it wouldn't matter. You're gonna pick a 1 and a 2 of the data points. They chose to do, I would guess here, what did they do? 4. Okay, so this is 1. This group right here is 1, and this group here is 2. What they did, and I can tell because I can see for this 4 here in the y1, they put it right here. So I know that's how they did it. So I'm going to leave those markings up there as we talk through this one. And then we don't have an m. X minus x1. So we're going to, okay, here's what they're doing. Up here, we're finding out what m is. So they've taken y2, which is -2, minus y1, which is 4, and they put it over x2 minus x1, which gives us negative 6 over 3, and 6 divided by 3 is 2, and it keeps the negative, so we have negative 2. So now we know what the slope is. And then we can come over here and we can substitute in our values for our, that we need, which really only comes out of this one right here now. So first step, find m. Second step, use this and put it into this, this formula. All right, point slope form. All right, and that's pretty much it. That's how you're going to do. That's an example 2. And in the next example, example 3, the application 1 here, we have some real data. Parasailing. Oh, that would be fun. Being pulled back at the back of the boat. After 2 seconds, you are 25 feet above the boat. A, write and graph an equation that represents your height, y, in feet above the boat after x seconds. B, at what height were you parasailing? Oh, that's a good question. Okay. Substitute, we have to create an m, and we had our first point was, where was it? You're being pulled down at a rate of 10 feet per second. So the slope is negative 10. You're being pulled down. You are 25 feet above the boat after 2 seconds. So the line passes through 2, 25. So y is our feet and x is our time. So we have a point slope intercept here. We started at 45 because how did they start with 45? Okay, I think I got it here. Okay, so they've given us the thing here. They've given us the slope. I really wasn't paying attention to that, where they got that. And the 25 feet above the boat. You are 25 feet above the boat in 2 seconds. So they've given us enough information. So we have this 1 point. So this is really kind of a part of example number 1. We really have 2 different ways of working out things. Example 1 and example 2. And this is just filling out information like we had for example 1. So we've substituted m, which is negative 10. And they've put in x1, which is 2. And it was supposed to be minus 2, right, the form. And then we have minus y1 here, which is 25, and etc. And then they simplify by multiplying this in. So which puts us into slope-intercept form. This is what got us into slope-intercept form. They simplified. So right here they added 25 to both sides, because when you have a negative number, you have to add it. So we add it to both sides. And plus 25, and that left y by itself, and then this didn't change because there's no need to change it, and then adding the 25 and the 20 together gave it 45. So there we go. On to problems 2. Okay, I'm just going to go straight through. So I'm not going to cover the review questions very much, but I am going to cover day 1 and day 2 problems. For the first day, you're going to do problems 3 through 5, and then the review questions at the end. So we're going to use point slope form. We're going to write an equation of the line with the given slope that passes through the given point. So number 3 here, we have a slope, we have a given point, and we're looking for point slope form. If we go back to the beginning, remember point slope form is, I believe it goes like this: y minus y1 equals m x minus x1. I'm just going to go back and check real quick. All right, here we go. This is going to be, I'm going to do number 3 so you can see how to do it. I'll leave it here so I can see my slope stuff over there just a little bit. All right, first thing I'm going to do, I'll just write it over here again. I need y minus y1 equals m, my slope, x minus x1. There we go. Now, first thing I'm going to do is I'm going to substitute in what I have. Right here is my point 1, or coordinates for number 1, which is a negative 2x and 0 on the y. Looks like, yep. So as I substitute it in, it's y minus 0 equals 1/2, and then I have x minus and minus 2. So I'm using parentheses if you don't notice. All right, it says use point slope form. I went all the way to line intercept, but here we go. I'm rewriting this in point slope form. All that I need here is y equals, because this is 0 out, 1/2, and then I need x. I've got negative times a negative there, and negative 1 is understood on the outside. So x plus 2 on the inside. Now I have solved it, more or less. The next thing we're going to do is we are going to erase this circle, and all I need is the slope now to solve the rest of this. I'm going to use this slope right here. It's just not giving me a dot like it should. There we go. Slope. Here's my slope. It's 1/2, or right there, 1/2. So that means I'm going to go up 1, and then I'm going to go over 2, which puts me right here. And I can do it again. I'm going to go up 1, over 2, put it right there. I could go down 1, over 2, or backwards 2, so I can run it backwards as well. Whatever the case is going to run through just like that. This is really all you need. You need this graphed out on your paper, and you need this right here. Not all of them are going to come out with just a y by itself. The only reason this is by itself is because this was 0. If it's not 0, it's not going to come out like that. And let's see, and right here, this one isn't 0, and this one isn't going to have a 0. We won't have a y of 0. This is a y of -1. This is a y of +3. So we won't come out with the 0 like I did on this one. Just letting you know. All right. So that's numbers 4 to 5, or that's how you do 3 to 5. We'll go quick. Okay, this is how you do number 1 and number 2. Number 1, you're going to use this information here off of x1 and y1. You're going to pull that information out of this. It says identify the slope. You already know where the slope is. It's right here on that equation, and a point on the line. This is example 1. Then this next problem number 2 is using both example number 1 and example number 2, because example 1 is you're using its slope and a point. That's example 1, and then on the line. And then example number 2, you're using 2 points on the line to figure out what this equation is. So both those things are 1 and 2. Is just making sure that you understand it. Number 7, you're going to do odds 7 to 21 on this assignment, and I'm going to use, this is example number 1, how to do it. Here's my information. I'm going to write out my number 7 here. I'm going to write out my formula, which is y minus my y1 equals m x, parentheses, x minus x1. Now I'm just going to substitute my information that I already have right over here. Right there. I've got y. That doesn't change. My y1 is minus 8 equals, my slope is 3 over 4. That's what it says. M equals 3 over 4. And it's not positive or negative. It's just positive. It's not negative. And then I've got x minus my x1, which is 4. Now, it says write in point slope form an equation of the line that passes through the given point and has the given slope. That's pretty much all there is to that. That was really easy. And number 2, or number 12, I'm going to do one of these. This is example 2. These ones are going to be a little more work because we have to find the slope and then put it in this other form. So here is, I'm not going to do 12, I'm going to do 13. And 13's, well, we're going to find the slope first. M equals y1 minus, wait a minute, it's the other way around. Doesn't matter, we just pick one of them. This one's going to be 1, and the second one's going to be 2. I think it's y2 minus y1. And over x2 minus x1. And then I'm going to start putting in my numbers. I'm going to do the bottom first because otherwise I get confused. So it's x2, which is 3 minus 2. And the top ones are 6 minus 4. Because I'm doing the two numbers first, subtracting these numbers from those. And then that gives me, my m is going to equal 2 over 1, which equals 2. Right? Make sure that's right. Double checking. And 2, yep. This is 2, and this is 1. Yep. So my slope is 2. And then I'm going to start putting in my formula information. So I've got my slope. And now I'm going to use the ones here to figure out the form. So I got y minus y1 equals my slope, and I've got x minus x1 in parentheses. There we go. Now I'm going to substitute my numbers. I've got y minus y1, which is right here. That's some 4. And then I've got my slope, which is 2, times x negative, and my 1 is 2. And let's make sure I've done everything it says to do. It says write the slope intercept form an equation of the line that passes through the given points. All right, write in slope intercept form. Let's make sure I did it wrong. Oh, no, I didn't do it right yet. So I got one more step. I have to turn it into slope intercept. So I'm almost there. Last thing I need to do is I need to take this over to the other side, and I'm going to distribute this into these because my slope intercept form is actually y equals mx plus b. And yeah, this will get me this will get it for me. So I've got all right, here we go, mx plus b. And then all right, so I'm going to solve it. We got 2x, and then 2 times 2 is minus, or 2 times negative 2 is minus 4. And then I'm going to add the 4 to both sides, plus 4 here. And let me erase this so it's out of my way. And then y equals, my slope doesn't change. Oops, shoot, I'm doing the 2x, the 4's cancel out. So here's my slope intercept form for number 13. Do your review so that you can see what you're doing on the first day here. Graph the linear equations. This is not a hard part. We can handle this. All right. Let's see. Y equals 4x. That means the y, or that means this is going to start on your graph. Your b, which isn't showing here, starts right here in the middle. Just to remind you. And then, okay, and then your slope is 4 over 1. So it should be easy to graph that without doing anything fancy. Same thing with this one. You've got a slope of negative 1, so that means you're going to go down 2 over 1. And then this one you're going up. How many? Okay, I'm going to leave you with that. I think you can do the rest. And then the last one, what is the x-intercept of the equation? Remember, finding x, you have to zero out and solve for x, right? So we're going to zero out this one. You should be able to solve it. I'm going to show you how to do number 19 here, because it is a little bit confusing. First thing it's going to ask us is, cars, after it is purchased, the value of a new car decreases $4,000 each year, and after 3 years, the car is worth $18,000. So we're writing an equation where V in dollars and the car X years after it's purchased. Okay, so here's where these are the numbers you need to pay attention to. The car is losing $4,000 of value each year. It was purchased new. Doesn't say that up here really exactly. Oh, there it is. New. It's decreased $4,000 each year for 3 years. After the 3 years, the car is worth this amount right here. So we're writing an equation that represents V in dollars of the car after it is purchased in X years. We know how much, we know how much it's losing each year. And so that is going to be 4,000 times X. X is representing years. That's what it says right here. And so 4,000X after it is purchased, we need to know how much did it cost when they purchased it. So you have to work backwards. If it's worth 18,000 now and 3 years it's lost this, I need to multiply 3 times 4,000 and then add that to 18,000, and then that would tell me what my value of the car is, and which is going to be, oops, you're going to put that there. I'm not going to give you the answer. You can work out the math. So your equation is going to look like and this, let's see, this equals m. I'm just going to say m. No, I'm not, because that's slope. Let's say c for car. So here's what your equation should look like. It should be v equals, you're going to use this right here, 4,000x plus c. So you have to figure out what c is. And then what is b? What was the original value of the car? And that is that equation thing right there as well. And for number 21, you're going to figure out Dolbear's law. You can predict the temperature T in degrees Fahrenheit by counting the number X of chirps made by a snowy tree cricket in 1 minute. For each rise in temperature of 0.25 Fahrenheit, the cricket makes an additional chirp is made each minute. That is really fascinating. So here we start out. We've got some basic information that, first one here, cricket chirps 40 times in 1 minute. All right, a cricket chirps 40 times in 1 minute when the temperature is 50 degrees Fahrenheit. So this is 40 per minute and 50 degrees Fahrenheit. And then this is the thing we need to pay attention to up here. Write an equation that represents the temperature in terms of the number of chirps in 1 minute. So, this is one of those hard ones again. Okay, we're going to translate. First thing we're going to do is we're going to take the given information and translate it into math. So the first thing we're going to use is T is going to equal our temperature. Temperature, I'm just going to say temp in degrees Fahrenheit. X is going to equal chirps per minute. And the rate of change is going to be, so this is stuff you want to write down just so you can get it, is 0.25 degree per chirp. Per chirp. Here we go. Oh, this is really good. This helps us get more comfortable with the formula, actually. Check. So here we go. We're going to step 2. So this was step 1. This is step 2. We're going to use this as our y, and this is going to stay our x. It's just easier to do it that way. So we're going to have a point. We're going to given point, because we've been talking about having a given point. For example 1, x is still x. The t is going to stand in for our y, or be the vertical point on our graph, which is time right here. And x is going to stay this way, going that way, okay? And we have the 2 points, which are the time, if we go back and look at our thing, is 40 times in 1 minute right there. So I'm going to substitute my 40. And the other thing is 50 degrees Fahrenheit. So here's our point and 50 degrees Fahrenheit. And there we have our first points on the graph, which would be, you know, approximately, it's over 4 this way and up 5 this way, somewhere right in there. And then we're going to write the actual equation, which will be, remember, intercept slope form, mx plus b. So here it goes. Substituting in, here's my y, 50. I don't have, oh, I do have a slope. It's right here. So the rate of change, or slope, is that, and it is going to be 0.25. Then I have my x, which is, well, whatever it is. It doesn't have to change on this one here. X plus 40. That's the thing. Looks like I jumped ahead just a little bit. So in 21, we need an a. And the a is, it starts right here. I have, the things I do have are m equals 0.25, 0.25, and my b is going to be 40. So this is the way it looks. It looks like this. Y equals 0.25x plus 40. There's A. B asks us, you can count 100 chirps in 1 minute. What is the temperature? The chirps per minute is represented with the x, so I am going to rewrite this one. For this one, it's going to be, actually, oh, I messed up. I don't want to. If you write this with a y instead of a t because of me, that is just fine. This is supposed to be a t. And so then we're going to substitute our t's in here for b. Keeping the t here, we don't have the temperature yet. We're going to do 0.25 times, it said 100 chirps in 1 minute, so that's 100 for the x, because x equals chirps in 1 minute, and plus 40. That's step one. Step two is to solve it, and I'm not going to solve that for you on the video. And then for the next one, for C, the question is if T equals, well, it says if the temperature is 96 degrees, which is our capital T, then if T equals 96, then how many chirps would you expect the cricket to make? So I'm going to substitute my T into our equation that we have actually in A. So we're going to substitute the 96 into here. And then so that goes like this. 96 equals 0.25x, because we want to know how many times he's going to chirp in 1 minute. So this is what we're solving for, plus 40. And since we only have one variable to solve, which is x, it's very solvable. So just work it through. Remember, we have to put x by itself. So I would leave x on this side of the equation right here. I'm going to subtract 40 from this side to put it on this side. That's the first step. And then the next step, after you've done that, is to divide by 0.25, because this is a multiplication. 0.025 or 0.25 times x is multiplication, and to undo multiplication you divide. So I'll let you work that out to finish it.